So students, now let us discuss about some of the merits, demerits and the limitations of the Mendeleev's periodic table. So here we have a Mendeleev's periodic table that we have discussed previously. Now let us discuss about some of the merits of Mendeleev periodic table. So our next topic will be merits of Mendeleev's periodic table. Now, what will be the basic merits of the Mendeleev periodic table? We have observed that firstly, Mendeleev gave the systematic classification of the elements known until now. He also described, after the systematic classification, he gave the corrections of some of the atomic masses, and thirdly, what he will able to say about the periodic table will be. So, what are the general merits of the Mendeleev's periodic table? Firstly, he gave the systematic classification of the periodic table. Secondly, he tell us about the position of noble gases in the periodic table, and he also gave the classification about the correction of the certain masses in the periodic table. So, what are the merits of Mendeleev's periodic table? We can learn them by a simple flow chart. Firstly, he gave the systematic arrangement of elements. Secondly, what we came to know about from Mendeleev's periodic table, corrections in atomic masses. Thirdly, he will give the position of the noble gases in the periodic table. So, position of noble gases have been identified. So, here are these of the merits of the Mendeleev's periodic table. So, now let us discuss these 3 points in a detailed way. So, starting with our first classification, that he gave the systematic arrangement of the elements. Now, let us discuss our first point, systematic arrangement of elements. So, in Mendeleev's classification for the elements, we have seen that he gave the systematic arrangement of elements. What does this point is going to specify here? That in Mendeleev's periodic table, the elements are arranged accordance with their increasing atomic weight in consideration with their physical and chemical property. So, we get a systematic arrangement of the elements from Mendeleev's periodic table. So, what he has said about this? Elements are arranged in increasing order of atomic weight, or we can say that increasing order of atomic masses by considering their physical and chemical properties. By considering their physical and chemical properties. Secondly, the point he has said that he has done a corrections in the atomic masses. So, what will this point is going to specify here? Earlier, the mass of the beryllium, that is Be, atomic number 4, has been considered 11.9. But when the mass is corrected, the mass of the beryllium has found to be approximately equal to 9. So, he gave the corrections in the atomic masses of the some element. So, our second point will be corrections in atomic masses. So Mendeleev corrected the atomic masses of some of the elements, and the example I am considering here will be the example for beryllium. So the example we have earlier, beryllium having a symbol capital B small e, mass is recorded as 11.4 approximately. So earlier beryllium is having a mass of 11.4, but after Mendeleev's classification, after Mendeleev's correction, it was found to be 9.4 approximately. So for the beryllium, the correct mass will be 9 or 9.4, or we can say that AMU. Now this is all about the correction of the masses in case of the periodic table that is given by Mendeleev. Now what happened at the time, certain elements like germanium, scandium and gallium has been not discovered. So what Mendeleev has done, Mendeleev has left a space in the periodic table, and what he has pronounced these terms, he has pronounced these terms as a Eka boron, Eka silicon, Eka aluminium. And what does it is going to specify? Eka is usually a Sanskrit word which means one. Eka in Sanskrit means one. So he has left some of the spaces in the periodic table. So when the elements has been discovered, they can be replaced in the periodic table. So the next point about the merits of Mendeleev's periodic table is he has left some spaces in the periodic table. Why he has left some spaces in the periodic table? Because when elements were discovered, the elements that has been discovered later, and the elements that has been discovered later are scandium, gallium and germanium. Scandium, gallium, these three new elements has been discovered only after the periodic classification of the Mendeleev's periodic table. So what these names are represented in the periodic table, they are termed as Eka boron, Eka silicon and Eka aluminium. So these terms has been given to some of the elements that has been discovered later, and what does this word Eka is going to represent? Eka means in Sanskrit language it is one. So Eka boron, Eka silicon, Eka aluminium will be the names for scandium, gallium and germanium respectively. So these are the terms that Mendeleev has used and the left spaces in the periodic table. And this Eka is nothing, I am writing it here. This Eka is actually a Sanskrit word. This Sanskrit word means one. So Eka boron, Eka silicon and Eka aluminium has been used to specify such kind of terms. So this is the another merit of Mendeleev's periodic table. Now moving to our next category, that position of the noble gases. As soon as the Mendeleev's periodic table has been discovered, few elements like helium, neon were discovered. but they are present in very low quantity, they are present in very low concentration, and these are very less reactive gases. So they had not been placed in the periodic table, but some spaces has been left in the periodic table. So if they have to be substituted, the periodic table has not been disturbed. So what does it specify? In the position of the noble gases, at that time, helium, neon was found. These are actually noble gases. So these gases were discovered, but these are very less reactive because they are noble gases and they are present in very less concentration. So what Mendeleev done? Mendeleev has left spaces in the periodic table for such classification. Left spaces in periodic table, and these spaces are for noble gases. So the position of noble gases in some manner or up to the some extent has been classified by the Mendeleev. So you can see here from the merits of Mendeleev periodic table that Mendeleev's periodic table is a very big achievement in chemistry. So we can say that this Mendeleev periodic table is a great achievement in chemistry. It is a great achievement in chemistry. So Mendeleev's periodic table has its own significance. But apart from significances or merits, there also exist the demerits of some of the compounds. So you can copy it from here. So we can proceed to the demerits of the Mendeleev's periodic table. Now let us start about the demerits of Mendeleev periodic table. So let me rub this so it has been clear to you that what I have written here. Now, our next topic will be demerits of modern Mendeleev's periodic table. Now, apart from having some of the merits, Mendeleev's periodic table has some demerits too. And what are these demerits? First one is the demerit that Mendeleev periodic table has possessed is first drawback of the Mendeleev's periodic table is basically it do not specify the position of isotopes, and for secondly it do not give the periodicity in certain elements. It will not specify the anomalous behavior. It is not going to specify the similarity and dissimilarity of some of the elements. So demerits of the periodic table of Mendeleev are, so the first demerit is it do not specify the position of hydrogen. Secondly, it do not tell us about the position of isotopes. Thirdly, Mendeleev's periodic table do not fit for anomalous pair of elements. Fourth, there will be some dissimilarity and similarity. And the last one, it do not tell us about the cause of periodicity. So now let us discuss the demerits of the Mendeleev's periodic table now. Firstly, it will not specify the position of the hydrogen. So you have seen in the periodic table that hydrogen has been placed in the topmost part because some of the properties of the hydrogen will going to resemble with alkali metals and some is going to be with halogens. So he will not specify the position of the hydrogen, and firstly he has placed the position of hydrogen with the alkali metals. So we can say that firstly, position of hydrogen. So hydrogen is placed with alkali metals. It is placed with alkali metals, but some of its property can also resemble with fluorine, chlorine also. But some properties having resemblance with halogens also. So the position of the hydrogen is not justified by the Mendeleev's periodic table. Now the second demerit is position of isotopes. Isotopes of the element are the elements having a same atomic number but different atomic masses. So Mendeleev will not give idea about the position of the isotopes, that how isotopes can be filled in the periodic table, because if we are going to place the isotopes for the hydrogen, we have three isotopes, that is protium, deuterium and tritium. So how these elements can be placed, the position of the isotopes will not be considerable. So the second drawback is about the position of hydrogen. So Mendeleev's periodic table will not give an idea about the position of isotopes. So what basically the isotopes are? Isotopes means same atomic number but different atomic mass. So if hydrogen has the three isotopes, they are not given the separate places in the periodic table. So we can say that if hydrogen has three isotopes, they are not given separate places. So again, after the position of the hydrogen and the position of the isotopes is not justified by the Mendeleev's periodic table. So it is again the second drawback of the Mendeleev's periodic table. Now move to our third topic, that is anomalous pair of the elements. What does this statement specify here, anomalous pair? So we have seen that some of the elements present in the pair, Mendeleev have arranged the periodic table in the increasing order of their atomic mass. So what will happen here, some of the elements found in the table having a greater atomic mass as compared to the backward element. So this term has been failed, or this rule has been discarded, according to the Mendeleev's periodic table. So what is this anomalous behavior? I am writing it here. Anomalous pair of elements. What this anomalous pair is going to specify here, suppose we are considering potassium and argon. I am considering these two elements. So generally potassium is having a mass of 36.9 approximately, because potassium is having a mass of 36.9 and argon is having a mass of 39.6 approximately. So these are the, so you can see there potassium and argon is having a masses. Potassium is having a mass of 39.9 and argon is having a mass of 39.1. So potassium is placed before argon in case of the periodic table, which is not justified the statement of the periodic law. It means elements are arranged in the increasing order of their atomic masses. So argon has to be placed before potassium in the periodic table. But what we have seen here, potassium having a greater atomic mass, that is 39.9, is placed before argon. So this rule is discarded because it is showing the anomalous pair of the elements. And similar case is occurring with the another element too, that is cobalt and nickel. For cobalt and nickel, this rule is again not following. So this pair of elements, that is the anomalous behavior, has been discarded. Now let us consider fourth topic, the similarity and dissimilarity. What this point is going to specify here, similarity means in the periodic table some of the elements with the dissimilar nature are provided in one group. Suppose gold, silver and platinum, it means they are placed with the periodic table, they are placed with the alkali metals in the periodic table. So these do not have a properties like that. And manganese is placed with halogens, which is completely not appreciable. So what will be the fourth point? Fourth point we have is similarity and dissimilarity. So I am rubbing it from here. So the fourth point we are considering here will be similarity and dissimilarity. So according to similarity and dissimilarity, there are certain elements. So let us have a list of that elements, like gold and silver. These gold and silver are placed with alkali metals. These are placed with alkali metal in the Mendeleev's periodic table. And if they are placed with the alkali metals, this point will not be considered here. So this will be the wrong prediction. Secondly, the manganese element, that is Mn, is placed with halogens. They do not have any property similar to that of the halogens. So this idea is again discarded because the manganese do not have any resemblance with halogens. Manganese do not have any resemblance with halogens. So again this point will be discarded because these 2 points will not be a consideration of any type of situation. Now this is the basis of similarity and dissimilarity on the basis of the Mendeleev's periodic table. Now let us consider, so this point is also discarded. Now let us discuss about the cause of periodicity. That periodicity means elements on the basis of their physical and chemical properties are going to reoccur at the regular interval of the time. But what will be that cause of periodicity will not be explained by the Mendeleev's periodic table. So, next point, that is the fifth point, that is cause of periodicity. This cause of periodicity is not explained by Mendeleev. So, from these points, we can consider that Mendeleev's periodic table, apart from many of the merits, have not been considered as a standard by many of the scientists. But this periodic table has a great achievement in the field of the chemistry, and this will set up a mark for the further inventions. So this can't be ignored. This is considered for the further discoveries as well as. So let us move to the next discovery that has discarded the Mendeleev's periodic table is modern periodic table. So let's discuss the modern periodic table now.